Can you find the area of this blue shaded semicircle? We are given a right-angled triangle with a base measuring 8 units and a height of 6 units. Inside this triangle, a semicircle is placed in such a way that its diameter begins from one end and lies along the base of the triangle. And this hypotenuse is tangent to the arc of the semicircle like this. And our goal is to find the area of this blue shaded semicircle. You can pause the video and take a moment to think about it. And when you're ready, you can always come back to verify your answer. Alright, let's get started. We are told that the base of this right-angled triangle is 8 units, and the height is 6 units. So applying the Pythagorean theorem, we get hypotenuse squared is equal to 8 squared plus 6 squared. 8 squared gives us 64, and 6 squared gives us 36. So this hypotenuse will be equal to 64 plus 36. Which is equal to 100, and taking the square root of 100, we have the hypotenuse is equal to 10 units. That means this length here is equal to 10 units, right? We are also told that the center of the semicircle lies somewhere along the base of the triangle. So let's mark the center point right here, and draw a radius from the center upward to the hypotenuse, like this. So this is our units, and this is also our units. Now take a closer look. If the total length of the base is 8 units, and this part of the base is r, then this remaining length from the right corner of the triangle to the center of the semicircle must be 8 minus r units, correct? We know that according to the radius tangent theorem, that is, whenever a radius drawn to a point of tangency of a circle, then radius is always perpendicular to the tangent. That means this angle here is 90 degrees. We now know several lengths, but we still do not have the exact value of r. So here comes the tangent from an external point theorem, which says that when tangents are drawn from a single external point to a circle, the lengths of the tangents are always equal. That means the length of this tangent is equal to the length of this tangent. Since this part is 6 units, this part must also be 6 units. Now if this full hypotenuse is 10 units, and this part of hypotenuse 6 units, then this remaining segment must be 10 minus 6, or 4 units, correct? Let's now focus on this smaller right triangle formed between the center of the semicircle, the base, and the point of tangency. One leg is r units, the other leg is 4 units, and the hypotenuse is 8 minus r units. So again, applying the Pythagorean theorem, we have r squared plus 4 squared equals the quantity 8 minus r squared. Simplifying this, we get r squared plus 16 equals 64 minus 16r plus r squared. Canceling r squared from both sides, we get 16 equals 64 minus 16r. Now subtracting 64 from both sides, we get negative 48 equals negative 16r. And dividing both sides by negative 16, we get r is equal to negative 48 divided by negative 16, which is 3 units. That means the radius of this semicircle is 3 units. Area of a semicircle is calculated by the formula 1/2 times pi times radius squared. So substituting r equal to 3, we get area equals 1/2 times pi times 3 squared, which is equal to 1/2 times pi times 9. And finally dividing by half, we get area of this semicircle is equal to 4.5 pi square units. And that is our final answer. Pretty amazing, right? Just a few geometric constructions and some smart use of theorems gave us the exact answer. But wait, before you go, here is a quick bonus challenge for you. Can you find the area of this same blue shaded semicircle in terms of a variable x and variable y instead of numbers? Think it through and drop your answer in the comments below. Let us see who can figure it out. If you found this explanation helpful and learned something new, do not forget to hit that like button, share it with a friend, and subscribe for more mind-bending math puzzles. Thanks for watching, and I will see you in the next video.